Hi, this is Mr. Moss, and in this video, we're going to be working on adding multi-digit numbers. I'm going to be showing you two different ways to add multi-digit numbers. And the first strategy that we're going to start with is called the standard algorithm. It's the traditional method. It's the way that so many of us adults learned how to add when we were growing up, and so many of the kids have learned, whether from their families or from younger teachers of younger grades. This is, for most of us, the way we all learned how to do it. And so for a standard algorithm, I'm always starting in my smallest place. I'm always starting in my ones place. And I'm going to begin here adding 4 plus 7, and that's 11. So I'm going to put down my 1, and what do I do next? Well, if you're like me, you may have learned growing up that we say that we carry the 1. Standard algorithm is still a perfectly good way to add numbers. I don't want anyone watching this to think, oh, that's not allowed in the new math program or anything like that. Standard algorithm is a terrific way for kids to add math, but I do want us to move away from the idea of using carrying as a word to describe what we're doing here. Carrying, when I talk to the kids in class, we call that a math swear word. That it's not a word that we use because it really doesn't have any meaning to what we're doing. We're not lifting up anything. I guess you could say we're hoisting it up here, but really carrying isn't a mathematical term. Instead, we want to build kids' math vocabulary. So instead of carrying, what we're really doing is regrouping. So 4 plus 7 equals 11. We put down that 1 for the ones place, and we're regrouping that 10 right over here. 7 plus 1 equals 8. Then we're going to move on. 8 plus 3. Oh boy, I think I'm going to need to regroup again. 8 plus 3 is 11. So I'm going to put down that 1 in the ones place. And the 10 goes over there. 1 plus 2 equals 3. Plus 9 equals 12. I'm putting down that 2 in the ones place. And I'm regrouping my 10 up there. 4 plus 1 equals 5. Plus 2 equals 7. And my answer, 72,181. So this should look familiar to many folks. This is, again, the way that so many of us learned how to do it growing up. The next strategy that we're going to look at is called the partial sums method. Partial sums is a little bit different. If you think back to maybe you watched an earlier video, or maybe your child has shared with you the idea of expanded form or decomposing a number. When we decompose a number into expanded form, we look at some of those parts that make up a particular number. So in this case, we've got 42,874. So that's 40,000. That's what the 4 represents, plus 2,000, plus 800, plus 70, plus 4. For 29,307, that 2 represents 20,000, plus 9,000, plus 300, plus 7. We don't worry about saying plus 0 or anything like that. You don't need to write out the expanded form in order to use the partial sums method. It's something I'm doing here just to remind you of what it is to decompose a number into expanded form. But really, you don't even need to worry about this in order to add it up. For the partial sums method, in the traditional method, in the standard algorithm, if we go back for a second, to solve it, you're always going to be going, starting from the right, moving to the left, starting from the ones place, going to the largest place values. But with the partial sums method, you're going to be starting with the largest place value, whether that's, in this case, the 10,000s, or if we had a different problem in the millions, whatever it happened to be, you start with the largest place value, and then you'll work your way over to the smaller place values. And here's what we do. So I have here 4 plus 2. Well, that's not really 4 plus 2. That's 40,000 plus 20,000. I know that 40,000 plus 20,000 is 60,000. Look at that. I'm keeping my numbers nicely lined up in columns. Keeping your work organized is so important. For a lot of kids, I recommend that they use graph paper to keep their work organized. So I have 2 plus 9. And again, what is that worth? That's really that's 2,000 plus 9,000. And I know that 2,000 plus 9,000 is 11,000. So again, keeping all my numbers organized. 8 plus 3, it's not 8 plus 3, it's 800 plus 300. So that's, again, 1,100 or 1,100. That 7 isn't just a 7, it represents 70. That's 70 plus nothing here. So that's 70. And in this case, 4 plus 7 really truly is 4 plus 7 equals 11. And now I have to add up my partial sums. That's why we call it the partial sums algorithm. I got the sum of these digits, the sum of these, of these, of these, of these. So now I need to add that up. And for that, I do use the standard algorithm. Going across here, that's 1. 7 plus 1 is 8. 1 plus nothing is 1. 2. 7. 72,181. And you'll notice we got the same answer we got previously, 72,181. So the question is, which do I prefer? Which do I recommend? And it's kind of a tough call. Standard algorithm is obviously a faster strategy, but it doesn't really teach kids the concept of why that works. For example, when you do 2 plus 9, and hey, we even regrouped right here. Remember, we're not saying carrying. We regrouped, and we put a 1 up here. Well, what does that 1 mean? And 2 plus 9 plus 1 may equal 12. So here's the 2, here's the 1. But it's not really 12. We're in the thousands place here, or the 10,000s place here. It gets you the right answer, but it doesn't teach you why. Whereas partial sums does teach you why. We're looking at what each of these numbers really is made up of. So we've got 40,000 plus 20,000, that's 60,000. 2,000 plus 9,000 is 11,000. 800 plus 3, you get the idea. It helps kids to understand why the answer is 72,181. It reinforces students' understanding of number sense, of place value, by being able to interpret what these numbers are in expanded form, even if you're not writing them out, just to be able to say 800 plus 300 equals 1,100. It helps to improve those skills. So it does take longer, I'll be honest with you, but I think it builds that conceptual understanding. So my recommendation is start with partial sums if your kids are just beginning to learn how to add multi-digit numbers, and then kick in with the standard algorithm when they're ready. We teach both of these in class, and it's usually a pretty even split on what students prefer. Let's do one more example here, and I'm going to again show this to you in both methods. Standard algorithm. All right, 1 plus 2 is 3. No regrouping needed here. 9 plus 7, now I do need to regroup. That's 16. So I'm going to put down that 6, regroup the 1. 3 plus 5 is 8, plus 1 is 9. No regrouping needed. 7 plus 7, that's 14. Put down the 4, regroup the 1. 8 plus 1 is 9. 2 plus nothing is 2. So not too much regrouping needed there. And now let's look at partial sums here. Again, I start in the largest place value, and then I work my way over to the smallest. So 200,000 plus nothing here is 200,000. In this case, no 10,000s, that's easy, plus 80,000 is 80,000. 7,000 plus 7,000 is 14,000. 300 plus 500 is 800. 90 plus 7 is 160. And 1 plus 2 equals 3. And now if I go to add up these numbers, I've got 3, 6, 9, that's a fun pattern, 4, 9, 2. Both of these, 294,963. So both of these are going to get you the right answer. It really is a personal preference. I want kids to be able to add the multi-digit numbers, whether they're doing standard algorithm or partial sums is generally going to be up to them. I want them to understand both strategies, but in the end, they're going to be able to choose which one is right for them. This has been Mr. Moss working with you on adding multi-digit numbers, and I hope this was a helpful guide for you. Have a great day.